Action.
2019 November.
2019 November. Okay, question 1. But figure 1 shows a connection at the tie beam bottom boom of a steel roof truss where two discontinuous. So the thing that you should note, but discontinuous again. So discontinuous. So if one filler it is still rolled angles, but they are discontinuous, we use 0.85. And then if it's continuous, if it is continuous, we use 0.7. Yeah, 0.7. So now, but this one is discontinuous again, meaning we're going to use 0.85. Okay, and then are connected to the tie beams by means of 8mm gusset plate. So this is the figure 1.1. The part marked T here is this one, is bolted to the gusset plate with grade 4.6 M16 bolts. So here I saw about M16 bolts. Again, this 16 is the diameter. D again. Any number that comes after letter M is diameter. So our diameter is 16 again. And then by determine the number of bolts, they want the number of bolts. We have the diameter, but we have M. And then required to secure the part T to the gusset safely. The thread of the bolt will be in the shearing plane. So if we're given something that is in the shearing plane, let me give an example of the bolts. If we have a bolt like this, these lines again, they are sheared. It's a fully threaded bolt. Maybe so, won't give one of the lines again, and then give us off. More car, spaces in car, what's which are shearing plane, shearing plane. I get like one of the 2 plates more, and then in between, a shearing plane again. So the line J, so this is our bolt, it's a full bolt like one. So if the line J didn't cover the whole bolt, it's called a fully threaded bolt. Again, this bolt is a fully threaded bolt. Inside the shearing plane, something. Shearing plane, the line J and one. Mara, if more there was nothing, this would not be a fully threaded bolt. There is nothing inside the shearing plane. So here question, but there is something in the shearing plane. I can remember in the shearing plane, it's a fully threaded bolt. You saw. I don't have these lines again. So if particular saw, but it's inside the shearing plane, and it's really a PV. PV stress, is it stress or what? Yeah, PV is equal to stress. PV is equal to stress, which is given in MPa. So, they did not give us any PV, like what? Yeah, they did not give us any PV, but they did tell us that all this is inside the shearing plane. So if it's inside the shearing plane, we use a PV of 100 MPa. We use a PV stress of 100 MPa. Then
If it's what?
In the shearing plane.
In the shearing plane, but
if it's fully threaded,
but the thread of the bolts will be in the shearing plane. But the threads of the bolts, I can tell you those lines get the threads. So what the threads they are inside the shearing plane. They can run the space the plate so shearing plane inside. So if the line gel and this zero again, the threads gel, I can the line those lines are the threads. If it is outside, inside the plate gel adjustment, there is nothing. I do for the line gel adjustment. Okay?
So, already, even fully thread, Mara isn't very was a mission or in the shearing plane.
No, Haley in the sharing plane rather it's fully threaded. I get
But your bolt is fully threaded.
hey. In the sharing plane, when I should know for it, it's a fully threaded bolt. And then outside the sharing plane, rather it is not a fully threaded bolt, it's a half threaded bolt. Okay? Okay, let's move. Question bar we determine the number of bolts. Okay? So we have a formula. We'll calculate the number of bolts.
Under two-way constant.
If
it's fully threaded. Alright.
If it is full.
So what n again? So we use this formula. It says F is equal to PV multiplied by N multiplied by area effective. Okay. F here it was PV is stress. I get 300 year and then N is the one that you want. Area effective. The area effective will vary it. Okay. There's a formula to find the area effective. So always, if I have a question, yes, or one you can and again, this is what you do. One formula you do it.
Everything.
So normally area effective again. So normally area effective so or diameter minus 0.9382 pitch squared all over 4. More normally pi is pi into d diameter minus 0.9382 p constant. Now we did for the bolts which I want to follow this formula more the bolts again. So this is constant. I don't know I'm gonna give you another formula more. And then p magic pitch. This p is for pitch and then squared divided by 4 again.
Pitch or never refer.
No, they did not give us the pitch, but we can get the pitch. So, how do we get the pitch? We have diameter of the bolt again, which is 16. So, when the diameter of the bolt, you go to the back of the book on page 329. So, more page 329, only M16 like one. I guess they gave us diameter 16. So pitch more next door ke 2. So if never feel M10, utalibala this table or which pitch again. They gave you diameter, you can get the pitch. They did not give you the pitch, but they gave you diameter of the bolt. So you use this table to get the pitch. So now more we have pi. So now we have pi again into what is our D?
16.
D is 16 minus 0.9382. What is our pitch?
2.
Into we got it from the table again. How did we get it? More table, only that M16 like one. M16 next door to M16, only pitch mark it 2 again. So that is our P and then you square it divided by 4. Here I calculate the area effective there.
So, if very Baltic M18 and you M18 was such a pitch.
M18. There's no M18.
Hey, whoever got a fire, never had a certified pitch rook, mana pitch gum. 156,668 for the legion. 56,668.
1 comma. Who can I confirm it?
Oh, well, check.
156.
I calculate that. I
156,67.
156,67.
Yeah, we should do.
You are like 67.
668.
Mutago Nugular answer wrong.
668 again. Okay. So, Renali area effective again. Renyakanali. question where le banyaka n. N ke number of volts
Number
again.
of volts.
Banyaka n. So this is the formula to find n again.
Yes.
Formula clear, and this is the formula. N is equal to F divided by PV times area effective. Mara, we did not have area effective. That's why I told you calculator area effective again.
Unit of measurement to move.
Are you sure? I'm not sure about the unit.
Area. Meter square.
Meter square.
Oh, say Mwala.
Meter. You want 56 inch millimeter square.
Yeah, it's millimeter squared.
It's even natural.
Millimeter squared. And then now, question is area effective again. The question wanted n. So n is equal to F divided by PV multiplied by area effective. So n is equal to F. What is our F? F is force. Here is the force. Anything given in kilonewton or newton is force.
Apa kerja pergi?
PJ area.
Baru point T. Macam kau jual mu question paper mu tu mu settings.
Mara you want the question mo?
Actually, but n ya T. So you're going to use the force for T. So which is 68 again. So after writing down the force, you need to multiply that 10 to the power 3 always again. Everybody in kilonewton like that. And then PV are like 100.
10 to the power positive 3.
Yes. 10 to the power positive 3, I get it 1000. Mano, area effective is like
156.
156,668.
Four.
Here for 4,34. 4,34 again. So once you got your n as 4,34, again, this is what you do. Use 4,34. We cannot round off Raisha 4. Mathematically, yes, 4,34. We can round it off to 5 again. Mara, here you round off to 4. 0,34 here, so what you do for the balls, if you are given even if only 4,1, you round it off to the next whole number, not nearest, and nearest, so to the next thing like 5.
Like about 4,001.
So 95 M16. M16 is okay. Here now what video. So you know MD. I get M again number of volts, which is 5. I can reround off, and then M diameter and I get like it's 16. So after calculating this, you round up to the next whole number again, and then so 5M16. If your diameter is M20, 5M20 like that again. So number 1, the answer really push your
Very monkey answer.
Oh yeah, bonala.
Okay, let's resume. Number 2, number 1.2, select a suitable equal leg angle section for the part marked S. We are going to focus on S again. We are done with T. So let's cut the rapport. Don't do the mistake. You S when you focus on T. But T, you focus on S. Make sure you reread the question. You read carefully. So select a suitable equal leg angle section for the part marked S. The total length of part P is 1,48. So it's for part S, 1,48 again. So what you do here, banyaka a suitable leg, equal leg. So what you do more is trial and error. It's possible you're going to try and then you fail. So you retry until you get it right again. And then if right now, let's say you calculated, you got a wrong answer, don't erase or cancel. You cannot do that. You reload again because of this again. I doubt that. I did say. Maybe what to rewrite the other one, but although it's wrong, it's correct or not. So the step that you do here equal leg is to go to the back of the table. Okay, first things first. Renali a force of 60 kilonewton more again. So what you do, you go to the back of the book. Only a table. Back of the book, From page 324 going back, 325 going backwards. These tables. Okay? And from 325 going backwards. So more, what you look for is for a force that is greater than 60. What you look for is a force that is greater than the one that you're given. More equal, we should select an equal length for S again, and the S we have 60 kilonewton. So more at the back of the book, more weight is written resistance. I think resistance like when I written kilonewton, and our force is in kilonewton again. So what you look for is for a force that is higher than that one. Yes, do
60.
higher than 60.
And then answer not
Our final answer is higher than 60. If it's not higher than 60, it's wrong.
83.
The resistant part.
Right now, we look for a force that is higher than the force that we're given, yes, on the resistant part.
But not big.
Not that big, but I will hold it. Don't
68.
58,
on page, ma.
322. I can relate 63.
Page 322, we have
we have
68.
68, we have 64, we have 63.
68. Around 68, the leg is 45 by 45 by 6 again. We look for that part here, designation millimeter, the first column, like one.
Ring 45 by 45
By 6. I can look at 68.
Di 356 jadi ya bereka.
64.
Ki 45 by 45 by 3. Ki 45 by 45 by 5. Ki 45 by 45 by 6.
What's the way?
Na pergi tu choose masalah.
And then where?
Baru designation unique 45 by 45 by 3. 45 by 45 by 6. KGP meter ye ai teni silo.
Really very good.
Ye.
Yeah.
Ito mo number ko na to lunch.
Ule khatile bukai 68. Resistance ya 68. Okay. So let us use it. Ki bukai leg here.
Leg.
What's the size of that leg? Take it leg, give me like that column here, designation mm.
45 by 45 by 6.
Like when I put 5 by 45 by 6. So now I use 45 by 45 by 6 again. One of the ones that you chose. Okay, and then more question 2. Are we not given anything?
Length.
They gave us length again. We need to write it down. What is the total length? The total length. Before choosing the leg, let's write the total length here.
1,48.
1,48 in meters.
Meters.
Again. Also write it in millimeters. You have 148 millimeters. Yeah. So what you do is to write down what you're given, which is the length, and also the force. What is our force?
60.
60 kilonewton. Yeah. First write down the given data and then go to the back of the table. You look for a force that is greater than that one. You choose a leg again. So this is called trial and error. You might not get a right answer. So what you do more? We are on page 322 right now again. We have chosen 45 by 45 by 6. So the next thing to choose is the area effective. Area effective or khetaya 45 by 45 by 6. Give okay.
0,4441.
Wait, I want area.
Oh, no area effective.
Area. It's in area. Let's choose area. It's in area effective. I want area.
Oh, say area.
0,509.
Area again. Give okay.
0,509.
0,509. SI unit.
Multiply by 10.
Multiply by 10.
The power 3. Millimeter square.
Millimeter square. Okay. Then R minimum. Choose R minimum there. There's R minimum on the leg that you've chosen.
8,66.
This is the table. Which one? 45 by 45 by 6. area area, and then
R minimum is
R minimum is this one, this column. So R minimum is
8,66.
66 millimeters. Okay, and then now what we do is to calculate the length effective. Okay, so now 1.2 we should select the suitable leg again. So the steps to select the suitable leg, number one is to write down your data again. They gave us the total length, they gave us the force. I choose 60 and then we choose a one that is greater than the one that we are given again, which is 60. We chose 68 again, and then this is the suitable leg, which is 45 by 45 by 6. And then you go and look for area on that 45 by 45 by 6 again, area and then the R minimum. Now we calculate the L effective. We don't get it from the table. L effective, how do we calculate it? It's the length, the total length that we are given, multiplied by 0.85. Where is this 0.85 coming from? They told us that it is discontinuous, and I told you if one is discontinuous, you use 0.85 again. So this is where that 0.85 works. If it was continuous, we would multiply by 0.7 again. So what is our length that is given?
1,48.
We use it in millimeters. 148 0 times 0.85. Remember?
1480 times 0.85.
Writing this down is about so when I and now I can want to read 1 2 5 8 The length is given in millimeters. It's given in millimeters, length again.
Yeah, millimeter.
Okay, so now I'm going to calculate slenderness ratio.
Slenderness. We like this slenderness. Oh, it's simple.
Calculate slenderness ratio.
So how do we calculate slenderness ratio? Any formula slenderness ratio? L divided by R again.
L divided by R.
L divided by R. Making slenderness ratio. So what is our L there? L effective. Here effective we calculate on what again? Here we working on L effective. Here we L effective here.
1258.
1258. And then what is our R minimum?
8,66.
8,66.
Oh, genius.
What do we get?
Okay, 170. 145.
145.
265.
145,265. So we have 145,265.
Our 266.
266. Okay. So 145,266. What do we do? Again, we have less slenderness ratio. Maybe what do we do from here?
Calculate the force.
Review.
Continue.
There is no calculator slenderness ratio.
No force, Elias stress.
Before more stress, you need to go to the table.
100 MPa.
Calculator. Load.
Page 326.
Oh.
I can recalculate. We need to go to the table.
Page
326.
326.
This one.
So
So how do you fit page 326 right?
Take it. Re khumane 145,266 again.
Yes.
Re tla mo renya ka.
Right, round it off or right, round it off.
Oh yeah, re skry randa. It's barely I tshwanela bo mo than okay. 100 26 145 minus 266 I choose ke bokae?
How about it's also with two decimal places?
No.
Negative 81 re round off.
Yela wena o nyaka go e dira. Ke yela ya column e ra so.
Eure.
Yela or if ke 22 kama 72 plus 22.
Asion.
Asiona.
Oh, wow.
Oh yeah, so rudie.
No.
It's also with
Really?
comma ke tshwanetse re beke pedi.
But yeah, so I get yes, hey, still column. Replace it for still column. If you saw 22 plus 72, I get right. If still this still column and this is a second or this is a square or any other shape, we round it off. As it very much. So
No, yeah, fourth. Yeah, rough.
before force.
Yeah.
No.
Awa. Yikenye.
Ana ba grandma ba tsebe bokala.
Go ke di tsema. Allah.
So more round it off here.
Right round off.
So any round off you like
145.
146.
145 one. 145.